I'm Gerhard. I'm here to talk to you today about my project called Litterbox, which I describe as somewhat isolated development environments, and through the course of this talk I will explain exactly what I mean by that. So, beginning. No, that's not great. Let's start with the problem that Litterbox tries to solve, which is essentially implicit trust. What I mean by that is, let's go back to the beginning. So this project started about a year or so ago, when there were a lot of very large-scale supply chain attacks all over the news, or still today. These were particularly in the NPM ecosystem, so I think there were 3 large attacks in 3 weeks, something like that. And that made me really scared, to be honest, and it made me realize just how vulnerable we all are as software developers. The risk really comes from these I don't know, package repositories, you can call them, like NPM for JavaScript, or Clercq for Python, Clercq.io for Rust, etc., etc. The thing with these repositories is that they make it really easy to add dependencies to your project. And that sounds nice, but the problem is it also means that all your dependencies have dependencies, and their dependencies have dependencies, and their dependencies have, and on and on. So you might think that you have 10 dependencies, but in reality you have hundreds, if not thousands. And you're implicitly trusting the developers of all of these dependencies to not put malicious code on your system. So either deliberately or just you're trusting them to not get hacked. And that's really scary because, I mean, what that means is whenever you run npm update, you're running the code that they shipped. And if it's malicious code, it's running on your system. And then you combine it with the fact that most desktop operating systems today don't give you any protection against that. So most platforms like Linux or Windows, any process running on your system just unconditionally has full access to your entire home directory. It can see all the files there, which could be SSH keys, other types of credentials, your browser cookies, like you name it. That's truly terrifying, I think. And then, I mean, it's not just if you do it's not just from the package repositories. So a lot of modern editors, so VS Code or Z or one of the million VS Code forks, a lot of their functionality comes from third-party dependencies, or third-party extensions. So you have exactly the same problem with all of these things. And I just felt like I didn't want to continue working with this, like having random code have full access to my system. I wanted to find a solution. And then, I mean, after this happened, another similar problem emerged called AI coding agents. I don't think I have to explain to anyone here what they are or what the potential risk is, but I mean, just in short, these agents typically have, they have the ability to run arbitrary terminal commands, which means that they also have full unconditional access to your system pretty much. These agents typically need internet access to be useful, at least in some situations. And I think it has become very clear that LLMs can easily be hijacked through prompt injection. And if they're spending a lot of time on the internet, that becomes quite likely. But even if they're not hijacked, I think we all know that sometimes they can just get derailed all on their own. So it's pretty terrifying to have these things running on your computer with unconditional access to. So I didn't originally want to build a solution to this problem. Ideally, I set out to try and find an off-the-shelf solution instead. But I couldn't find what I want. So here's a quick summary of the main things I could find. The first one is the obvious one, which is to just use a full-blown virtual machine. That gives you great virtualization back through hardware virtualization support. But I don't like it because it's too heavy for my development workflow. It's basically like having a separate computer for each project, which is just, I think it's a bit ridiculous. It's too heavy, like there's weak integration. I just don't want to do that. Then another option, which is something I've used with VS Code a lot in the past, is called dev containers. So that's basically just a thing where you package your entire development environment into a Docker container, which is nice because then it's portable across machines, it's nicely documented, you can even use it in your IDE, etc. The problem here is I don't think it was ever designed for security or isolation. That's not really a thing. And also the editor itself still runs outside the container, so you're not protected from the editor. The other thing is it requires tight IDE support, so you're locked to editors that support it. Then something I found which is sort of similar is called Distrobox, which also uses a container technology. But the goal of this Distrobox is that if you're running Fedora, for instance, you can have a Ubuntu distro box, and then you can run Ubuntu software on your computer as if it's a Ubuntu machine. But the nice thing is it's fully integrated and seamless, so your home directory is shared, your Wayland server is shared. It feels like your machine is like a chameleon or something. So that's great. The only problem with DistroBox is it has no isolation at all, and it's very explicit about not wanting isolation, not trying at all. So I kind of wanted DistroBox with isolation. And then I think it's worth mentioning that since the risk with AI agents became very obvious, like a lot of people have tried sandboxing these things, so like 1,000 of these projects come out every week or something. I don't know, it's crazy. I cannot possibly list all of them. I haven't really looked at many. And a lot of them, they only focus on isolating the agent itself. They don't really go bigger like that, like I wanted. I've listed 2 here which might be interesting, which are focused on agents. The first one is made by the same person who makes DistroBox, so that's interesting. I didn't really review it. The only thing I saw is that it's very complicated. So what I mean by complicated is this is the architecture diagram for it. And that doesn't mean it's bad. It just means it's probably very difficult to use, but it might work well nonetheless. So just to summarize what I wanted, is I wanted a tool that provides some level of isolation. It doesn't have to be perfect, but it should be better than what you get by default. I wanted to be able to use any editor or IDE, and I want to run that inside the sandbox, not outside it. And then in particular, I wanted to have special protection for SSH keys, because I mean, what commonly happens is if you use SSH to authenticate with GitHub or something like that, you use an SSH agent to store the key, and these things typically just authenticate all requests thrown at them unconditionally. So that means any code running on your machine just has access to your GitHub unconditionally. So I wanted something better than that, something that actually like prompts you to give permission for SSH key signing. The solution I came up with is called Litterbox. So, oh my soul, why is it doing that? Litterbox is one tool with 2 goals. The first goal, as I've already alluded to, is isolation. I want to be able to run things in a sandbox where they have very limited access to resources on my system. And then the other thing I wanted to have is reproducible environments. So I like this idea of being able to package and document all of my dependencies in a Docker image, move it across machines, and even use it in CI/CD. So Litterbox tries to solve both of these problems. Let me give you a very quick demo of Litterbox. Unfortunately, there's not time to go from the beginning, so let's just do a very quick demo with an existing one. Let me zoom out here a bit. So the first step is you enter the Litterbox. I only have one on this machine. Then it asks for a password to de-encrypt the SSH keys attached to the Litterbox. So now let me list what is in here, and then I can list one directory up. Oh. And I can even list the directory above here. This is all interesting because in reality, this Litterbox home directory exists on my real home directory under home, Litterbox, homes, tumble. But as you could see, everything above this tumble folder is just not visible inside the Litterbox, which is exactly what we want. So now I can show you quickly running a graphical editor. So this proves that Wayland and the graphics stack works, that Z is running inside the container. Then if I try to perform a git operation, my little dialog pops up. I can choose to decline, then the git fetch failed, or I can choose to approve, and then it pauses. And this is really useful because if you ever see that thing pop up when you're not expecting it to pop up, that means you've been owned, so you should kill this container and move on. So that's a pretty quick overview. Let's go back to the... Let me give you a quick overview of the architecture of Litterbox. It's not super complicated, but it has grown a little bit over time. So the first thing I want to show is that each Litterbox has its own daemon process running in the background, and this is responsible for the SSH key stuff. So you can choose which keys are attached to which Litterbox, and then upon startup, the daemon decrypts them with the password, and then it uses a Unix socket to expose the SSH agent into the container. So the keys never exist inside the container. It's only signing requests passing over a Unix socket. So that's basically how I secure SSH signing. Then the other thing you have is that I've recently added support for, you can have multiple sessions in the same Litterbox. So basically just multiple terminal windows connected to the same maintainer. It's not container. It's not multiple instances of the container. It's the same one. And then I've had to add quite a lot of complexity to deal with that nicely. So there's a log file to keep track of how many sessions you have active, so that I can terminate the container when you're done using it, so that it doesn't just keep running forever. And there's some complexity with like background fork processes and stuff like that. But overall, it's not that bad, and it's fairly well documented on the GitHub if you're a bit more interested. Something I wanted to mention is I've recently added landlock LSM integration into Litterbox, which is really nice. So if you're not familiar with LSMs or Linux security modules, these are basically kernel modules that extend the Linux security model beyond the simple user-based security model. So the standard model on Unix is just that processes run as a user and they have access to all files owned by that user. But with LSMs, you can be a lot more fine-grained than that. So for instance, you can have a web server and you can have a policy where that web server only has access to the files that it needs, like the folder with the HTML files or whatever. It just does not have access to anything else. So if the web server ever gets owned, like the blast radius is quite limited. And the two big LSMs out there are AppArmor and SE Linux. The ecosystem is split roughly 50-50 between those two. Originally, I was very sad about having to integrate support for those because they're very complicated to use. They require various policy files, especially SE Linux is a nightmare, and you require admin permissions. And those two you cannot mix those two, so you would have to implement support for both separately to support all distros. So that was really depressing. But then I found Landlock, which is awesome, because Landlock is just a library that you link to. No policy files, no root permissions, nothing. The process just calls APIs in the library and then it sandboxes itself. So that's great. And Landlock also works with the other LSM, so you can use it on any distro with a modern kernel, pretty much. And I mean, just to clarify why I need an LSM, is it's basically just because the way that containers provide file system isolation is through something called mount namespaces. But from what I understand, these things were never designed for access control. So there are various ways you can work around a mount namespace. So that's why it's generally recommended to also add LSM protection to really make sure that your isolation is sufficient. So that's currently what I use Landlock for, is just to have better file system isolation strength. Now, I want to be clear that Litterbox has a lot of known vulnerabilities and security holes. It's not perfect by any stretch of the imagination. Some are fundamental, whereas some are, I would say, accidental. So the biggest fundamental one is that because Litterbox uses standard containers, that means that everything inside the Litterbox is sharing the same Linux kernel as everything outside it. Which means that if anyone were to find an exploit in the Linux kernel itself, that would still be game over. Litterbox doesn't give you any protection in that event. The same goes for other shared resources like the Wayland server, etc. Then there are some accidental limitations as well. So Litterbox is implemented in Rust and currently uses a few crates, which means that Litterbox itself is susceptible to supply chain attacks. Unfortunately, that's the reality for the moment. Then another one worth mentioning is that currently Litterbox has very limited support for network isolation. It basically just has network namespaces, which give you some ability to isolate which things can talk to each other, but nothing fancy like based on the domain or anything like that. A lot of these AI agent tools do actually try to filter based on the domain name. I haven't worked on that at all, partly because I haven't had time, but also partly because I think it's a really difficult problem to solve. If you think about it, if you go for a allow list approach, it's gonna take a really long time to find all the domains that should be in the allow list. You're like constantly gonna be running into the firewall like every command you try to run it. gonna be painful, and by the time your list is sufficient, maybe it's pointless, like maybe the scary domains are there already. And then of course a deny list is just stupid. I mean, you're never gonna be able to know all of the dangerous domains. So yeah, that's the other reason why I haven't worked on it yet. So just to emphasize very clearly, Litterbox is not for running known malware. It's supposed to be better than nothing, but like, please don't run a virus inside it. And it's not anti-malware. Like, it doesn't try to detect if something malicious is going on in any way whatsoever. I use Litterbox daily for my development work. I tend to have different Litterboxes for different projects, each with their own dependencies, and then I run my full editor inside Zed or VS Code. I also use the same container images for CI/CD on GitHub Images, GitHub Actions. And then I tend to do a lot of embedded work, so I've added all sorts of odd random features to it, such as mounting devices. What's nice is that typically to create a TUN tap device in Linux, you need root permission, but inside a network namespace, you don't. So I can actually have my unprivileged scripts inside the container create a tap device, and then I basically use that to run an embedded networking stack on my computer. The goal is really just I try to run as much of my embedded software on my computer as possible to get feedback quickly without having to put it on the real device. But that's just a random aside. So finally, I would like to ask people to get involved in Litterbox. I have to be honest that, I mean, this is not something I'm super passionate about. I didn't start this project because I wanted to build it. I started the project because I felt I needed it. I couldn't find what I wanted, so I just built it myself. But if there's any of you out there who are really into cybersecurity, sandboxing, this type of thing, and would like to work on this, please reach out, because I would love to add passionate and trustworthy maintainers to the project to help push it forward. There's really a lot of work left to be done on the project. Documentation would be great, but the big one is to try and improve security and hardening. So as I've mentioned, currently I have quite a few dependencies. A really nice thing would be to reduce the number of dependencies and therefore get rid of the supply chain attack risk inherent in the project. And then something that could be interesting long-term is micro VMs. So I've already mentioned that full-blown virtual machines are just too heavy for this. I don't want to use that. But a lot of things have shown, like Amazon Lambda, for instance, that with micro VMs you can actually run containers with very minimal overhead, almost as good as native containers. So micro VMs could be a way in the future to take advantage of hardware virtualization to improve the isolation strength of Litterbox without paying too much of a penalty. And there's even things you can use to get graphics working. For instance, I forgot what the project is called, but Google has a virtualizer that they work on to be able to run Linux software on Chrome OS. So that has a way to like expose a lightweight Wayland like forwarding thing inside the VM so that your graphical stuff will still work as well. So yeah, that was a very quick overview of the Litterbox project, and I think I have a few minutes for questions now.
Hi. Have you heard about a project called Nix and NixOS?
Yes, I am aware of that.
Yeah, so the goal of Nix is like very similar, reproducibility and isolation.
Yes.
Has there been any efforts to maybe integrate Litterbox with Nix? I think some critical points here, like SSH keys. When you try to get pull or get fetch, it prompts you to confirm or deny. And maybe that's very useful for Nix too.
I'm aware of Nix, but I have never used it myself, and I didn't realize that they work on isolation. I thought it was only for reproducibility things. But I guess at the very least you can easily run a Nix container inside Litterbox. So it's not, Litterbox doesn't care which type of container you use. It's built on top of Podman. So if you can create a Docker file, you can run it. And it should probably run on NixOS 2. But in terms of any deeper integration, I'm not sure what is possible or useful.
So Nix is not necessarily a container, but rather whether it gives you a formal shell where everything is isolated. Yeah, maybe I would check it out.
Yeah, check it out, but again, I'm not sure what type of isolation Nix aims for, if it's from a security perspective or more just from a don't mess up your system perspective. Like, I don't know. Like, the thing is, I mean, I believe Nix is like oh no, I forgot it. It has like a read-only root file system, but it probably doesn't protect your home directory in any way.
No, it's completely isolated.
Okay.
So you basically have created like a nice user experience for like the SSH keys. So how do you, usually when you develop you need other secrets like environment, like tokens and whatever for accessing different APIs. Have you thought about like a nice way to simplify adding that to the container so you don't just copy everything because it's annoying?
I haven't thought too much about it, but I think it's really hard to solve that problem on your development machine. Because like, if you're exposing those keys into the container itself, with the SSH keys it's really nice because like there's already this protocol with the agent where it needs to go out and ask for it, and there's the signing which prevents the key from ever getting into the container. But I mean, for most other credentials, I don't think this mechanism is in place. Like, a lot of things are just a .env file or an environment variable or something like that. So then it's going to be really difficult to implement that in this system. I'm not aware of anything else that would work really nicely. In general, my recommendation would be to not have security credentials like that on your development machine at all. Like, you should always put your security credentials for production inside a CI/CD server, and then that should be the thing which deploys them. Like, if they are on your development machine, that's kind of a problem, actually. Yeah.
Hi. So basically, you can solve that with JWKs, JSON web keys. That you have the private key stored outside, and you sign each request, and you just have the public key of the J key in the API if they support it.
Yeah, I mean, in any sort of thing where there's like signing or asymmetric encryption, you can probably build something that works. I'm not aware of any other specific use case that is as common as SSH that has been worth implementing. But yeah, in theory, you could implement other stuff too. There's nothing preventing that from happening.
Yeah, they had it with, yeah, you just create the JVT out of the JVT. So it works.
Hi. First of all, I'm very happy that you're here and that you're making this project. I had this situation this weekend where I was basically looking into like how to isolate my development workspaces. I've tried web containers, I've experienced with Nix, I've tried virtual machines, and ended up exactly finding Litterbox as the solution to my problem. And I am intensely amused that that was 24 hours ago, and now I'm seeing you here at this conference. And I'm also so I'm also very glad that like you have the scope of your project is like fairly slim, and you're saying, okay, like other needs can be resolved by other like helper programs and things like that. So I'm a little bit nervous asking for like the one little thing that I'm kind of like I kind of wish there was is like with the home directory. Essentially, what I want to have, like, I want my developer workspace to be bound to a certain folder. So what you're currently doing is you have these like Litterbox home folders that are in like a separate directory, and then what I can do is I can just symlink to the place where I'm actually doing my development. But I'm kind of worried that like over time will cause instabilities. So what I'm currently doing is I'm using your like RON, like your like configuration, and I'm setting the custom podman mount to like mount my actual workspace into the Litterbox. But of course that's like manual labor, and it's like failure prone, because like I'm going to recommend like team members use this, and like stuff is gonna break. Like how do you handle this like issue of like, I imagine you don't want all of your workspaces to be like in a Litterbox folder, like there are Git repositories that are all over your computer. Like, how do we handle this, like, just mapping issue?
No, I do put all of them inside Litterbox. So,
Okay.
I mean, what I would do is that if it's multiple related projects, I would just put them all inside the same Litterbox. So you can have multiple Git repositories inside the Litterbox. That's not a problem. So that's usually how I approach it. I just have multiple ones. And then Litterbox does actually have a built-in feature that you can add podman flags. So you could use that to mount a directory yourself.
Yeah, that's what
That's one of the settings.
Yes.
And I actually think that symlinks won't work because symlinks get resolved in the mount namespace. So if you're symlinking to something outside the mount namespace, it just won't resolve. So I don't think symlinks are a viable approach. And I actually don't want symlinks to work because that would be quite a big hole for, for the system. But I haven't tested it, but they shouldn't work.